Hi everyone, next on our list is radical equations with the variable only appearing once. And again, what you should be seeing as like the underlying theme for any type of equations is if the variable only shows up one time on one side of the equation, figure out everything that's done to the variable and undo it in the opposite order. So looking at this first one, what I see is that the first thing I do is square root my variable, and the second thing I do is subtract 4. So to solve this, I'm going to first add 4 to both sides of the equation, and I'll get root k equals 5. And then I want to get rid of the square root. The inverse operation to square rooting is squaring. So we get k equals 25. Okay, so two warnings about this. One is just be thoughtful about that step. You're square rooting. How do you get rid of it? You square. I think people know that, but it's really easy to just kind of go on autopilot, and people want to get rid of the square root by square rooting the other side, and that doesn't work. We've got to do the opposite. The other thing is we talked about the properties of equality, and squaring both sides is another one that's not on that first list I gave you because you have to be just a little careful with it. Squaring both sides is sort of equivalent to multiplying both sides by something with a variable. So it's basically like we multiplied the left-hand side by root k and the right-hand side by 5. And that's legal because we know that root k and 5 are equal, so we should be maintaining our balance. The problem is that squaring is one of those things that can introduce a new solution. Sorry, stumbling over my words in my head. So this is another one where we can get extraneous solutions. So just like with the rational equations, we could do absolutely everything right and still get an answer that's not valid. It's a little bit harder to spot in these equations, but it certainly shouldn't be impossible, especially a simple one like this. It's pretty easy to do a full check. If we say root 25 minus 4, and we want to know if that equals 1, that's 5 minus 4, and it absolutely does equal 1. What you would be watching for is a sign problem, something like -1 equals 1 at the end, because what happens is when you square both sides, you can eliminate negative signs and make things that weren't equal before equal because of that. So you're just watching for somewhere where you wish that the sign was the opposite of what it was. Again, I don't think we will see some. We won't see a ton in this section. You'll see more in later sections. So let's check out the next one. So again, reverse order of operations, the subtleties that we have to worry about are when we're solving radical and rational. The steps along the way can introduce extra solutions, and when we're solving quadratics, introducing a square root does introduce some ambiguity, so we have to include a plus or minus. So those are kind of the little details that we have to watch out for as we go. Okay, so next one, I see my variable. The first thing that I would do, remember that the radical sign is a grouping symbol. So the first thing you do is everything under the root, which is multiplication. Then you'd apply the square root, then you'd add 8. So the first thing I'm going to get rid of is the 8. Since it's added, the inverse operation will be subtracting, and I get -11 equals the square root of 2s. The next to last thing was the square root. To get rid of a square root, we square both sides. So we get 121 equals 2s. And the last thing I need to do is detach the 2. It's attached by multiplication, so the inverse operation will be division. So we'll get s equals 121 over 2. Okay, and then that mandatory check, we have -3, and we want to know if that equals the square root of 2 times 121 over 2 plus 8. So we can eliminate those 2's, and we're asking ourselves, is -3 equal to the square root of 121 plus 8, which is 11 plus 8. And I would say absolutely not. 11 plus 8 is not -3, so this is not good, and we'll just say that was our only possible answer and it didn't work, so we'll say no solution. And WAMAP should have really specific directions on what you enter in these cases. Where I edited it to be no solution, but I think some they still want you to put D and E. So just read those directions carefully. I'll try and keep changing it so it's consistent, but I think there's a little that I haven't gotten to fix yet. About the plus or minus thing that I was mentioning, it's right here. If this had been a plus or minus root, the negative 11 would have been great, right? Negative 11 plus 8 is negative 3, but it's not. So this is where I think it's really easy to get confused. I know people get confused, and I totally understand why. When you introduce a root, the problem is that you're getting rid of a square, and when you square something, it could be positive or negative and give you the same answer. So it's a squaring problem that gives you plus or minus. Roots are really just like straight up about what they are. This equation had a square root in it. It's absolutely a positive root. There's no way to get a negative number out of a positive root. So even we could kind of see it if you watch as you go. Sometimes you can see them coming. Right in this step, negative 11 equals the square root of 2s. I can actually see there that that's going to be a problem because it's a positive root and you're not going to get a negative number out of it. So no solution is our final answer. And like I said, we'll see more as we go, but it's absolutely going to be something that we'll see where some equations are never true. That's what this is. So this original equation was a contradiction. It's impossible to make that true. And some equations are always true. Some equations are, it's called an identity. No matter what you plug in for your variable, it's a true statement. Or sometimes there's some small exceptions. There's a few things you can't plug in, but most things make it true. And then our usual is called conditional. I don't remember if I've used that word for you before. Again, I'm not really that worried about if you remember conditional, identity, contradiction, but I think it's good to say. Some people really kind of click with those words. They make sense. So conditional means that there's some finite number of solutions. Under certain conditions, it's true, and under other conditions, it's not true. This is a similar idea, really, right? Remember that a 1/4 power is a fourth root. But I really like to actually see these written as fractional exponents as well, just so that we can think about what that looks like. So if I have n over 5 plus 15 to the 1/4 power, the first thing I'm doing is dividing by 5, then I'm adding 15, so in parentheses first, and then the last thing is raising it to a 1/4 power. So you can think, okay, it's a fourth root. How do I get rid of a fourth root with the fourth power? You can also see that in that if we raise this whole thing to the fourth power, you would multiply 1/4 times 4, and that would give you 1. So I kind of like having both visuals. How do you get rid of a fractional power? You raise it to its reciprocal power. And we have to do it to both sides. So I now have n over 5 plus 15 is equal to 2 to the 4th, which is 16. The next to last thing is the adding 15, so let's subtract it from both sides. N over 5 is equal to 1. That's kind of nice. Last thing is that I'm dividing the n by 5, so I need to multiply both sides by 5. And I get n equals 5 as my answer. We can double check and make sure we don't have anything funny going on. So my check. So this is a memorized thing. When do I have this not optional check? You need to, whenever you're solving radical or rational, so if there's a root in it or if there's variables in denominators, you're going to need to do this mandatory check. For this class, those are the only ones we run into with that mandatory check. There will be others in 141. So this isn't the only time, but for now, it's all we have to worry about. Okay, so plugging in 5, we get 5 over 5, which is 1. Plus 15 raised to the 1/4, then we want to know, does that equal 2? 16 to the 1/4 does in fact equal 2. If you're still working on those roots, keep practicing. The fourth root of 16 is 2, because if you raise 2 to the 4th power, you get 16. So this is a great solution. We'll keep it. Okay, next one, a cube root. I'm trying to get the whole mix in here. Okay, so lots happening. The grouping symbol comes first, parentheses, right? And they're implied. So the first thing we do is multiply and subtract. After that, we would cube root 3. Then we would multiply again. And lastly, we would add the 3. So this order of operation stuff is really important. Okay, which means we want to get rid of the 3 first. Last thing happening, first thing to go. We were adding 3, so the inverse is going to be subtracting. So the 3 is gone, and on the right-hand side we have negative 16. This is making me a little nervous because we talked about the negatives, but there's 2 reasons that I think it's going to be okay. One is that the next thing I'm going to do is divide by negative 4. So I'm actually going to end up with a positive. Minus 7 equals 4. The other thing is this is a cube root, and actually we don't have any of that trouble with cube roots because you can take the cube root of negative numbers and you can get negative numbers out of cube roots, right? So we actually don't have any sign problems when there's cube roots. It's really just an even set, square roots, fourth roots, sixth roots, so on. Okay, next to go is the cube root, so we'll cube both sides. The inverse operation of cube rooting is cubing. 4 to the third is 64. 2 more, plus 7. So we get 2t is 60, 50, what are we getting, 57? Yep, 57. Okay, and then very last step, we need to divide that by 2, and there's our answer. We don't need the mandatory check with cube roots. It really is only square roots or fourth roots, but if in doubt, just check it, especially on exams when you have a calculator. I know on mastery quizzes, if you don't have a calculator, sometimes messy checks can be hard. I don't really think this one's going to end up being that bad. 57 minus 7. So we get the cube root of 50. Okay, maybe I do want to look. Did I do bad arithmetic somewhere? 4, 4, 16, 64. 57. Negative 4 times the cube root of 2 times 57 over 2 minus 7 plus 3 equals negative 13. Okay, so then, oh, I see my own mistake. See, this is why checking answers is good. We should have added 7 to both sides, so we shouldn't get 57. We should get, oops, 71. Okay. 71, and now let's see how that's looking. I was seeing a cube root of 57 going to come out of that, and I was not very happy about that. So the 2's cancel. I get 71 minus 7, which gets me back to my 64. This is seeming good. You should see some of those same numbers that showed up when you were solving. And we want to know, does that equal negative 13? And negative 4, cube root of 64 is 4. So I have negative 16 plus 3, and that does, in fact, equal negative 13. Okay, one more in this video. We will have that mandatory check, but as you saw in the last one, even when it's not mandatory, it can be a good idea. Order of operations, we would work in the implied parentheses first. So multiply by negative 3. Oh my goodness, what am I writing? That's first. Add 2 is second. Take the square root is third. Okay, so square root, remember, falls with exponents. It's the same as a 1/2 power. So roots and exponents are in that very top right below parentheses. And then multiplication, and then addition, subtraction is last. What in the world? I see my weird equation. I'm going to say, which did I want? 6. I'm going to say this one. Okay, so if we add 6 to both sides, we have 15 on the right-hand side and 5 root 2 minus 3u on the left-hand side. The next to go would be the 5, so we'll divide that out. And we get square root of 2 minus 3u equals 3. Okay, next to go. You can either look back at your list at the top or you can just reevaluate. Right now when I look at this, I'd say if I plugged in a u, I'd multiply by negative 3, I'd add 2, and then I'd square root. Square rooting is the last, so it's the first to go. To get rid of a square root, you would square. Always use the inverse operation. So 3 squared is 9. We're getting close. We need to get rid of the 2, so we'll subtract 2 from both sides, and we will get negative 3u equals 7. And then last but not least, divide by negative 3, because negative 3 was attached by multiplication, and we'll get u equals negative 7/3. Okay, so that mandatory check. We have 5 times the square root of 2 minus 3 times u. So 3 times 7/3 is 7, but it's a negative. I'm going to do one step in my head. You feel free to do as few or as many in your head as you want to. In general, I'm not actually checking your check. I'll just know if you missed it, because if there's an extraneous solution, you won't catch it. So always make sure you're checking. I don't really care what that looks like on your paper. Okay, so 2 plus 7 is 9. And then 5 times 3 minus 6. Okay, so 15 minus 6 is in fact 9. I'm going to go ahead and get rid of that and say yes, I am convinced. So 7/3 is a good solution. Okay, so that's our first look at solving radical equations. Thanks for watching.